Hi guys, greetings of the day. I Vijay Tavardhan. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on the bell icon to receive latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 23, which is for a third module where we are going to discuss in detail about the components and the hydraulic circuits as per the syllabus mentioned by the university. Now, let us go to the introduction part of the scene. A hydraulic pump converts mechanical energy into hydraulic energy, and the physical parameter that constitutes the hydraulic energy are the pressure P and the discharge of the flow rate represented by capital Q. The hydraulic actuator in a hydraulic system converts the hydraulic energy back into the mechanical energy, but situation arises wherein the output of the pump need not to be completely utilized. In addition to this, the motion or speed of the actuator need to be controlled and also need to be reversed. For reversing the direction of motion of an actuator, the direction of flow of oil has to be changed. In addition to controlling the direction of motion of the actuator, the speed of the actuator and the torque developed by the actuator need to be controlled depending on the requirement. And these controls achieved by controlling the following parameters of the oil, which has been energized by direction of flow, the discharge or the flow rate, as well as the pressure P. And a mechanical device which converts these parameters of a fluid energy is called as the control valve. Now, what is called as control valve? A control valves are a mechanical devices or elements used for controlling the fluid power parameters such as pressure P, discharge Q, and also the direction of flow. And the control valves of various types find their presence in almost all hydraulic systems and is similar to electrical switches in electrical circuits. The basic symbol for hydraulic valve is a square block representing the valve body or a valve envelope. The lines with an arrow with the same square indicates the direction of flow between the openings, and the opening is called ports provided in the body. A small perpendicular lines indicate the opening or ports in the wall. The change in flow conditions is achieved by different positions of valving element housed inside the valve body. And the figure shows the graphical symbol of hydraulic valve. Single envelope is used only for one flow path that exists through the valve, and multiple envelope symbols are used for more than one flow path exists through the valve. Coming to the classification of control valves, the control valves are broadly classified into two types based on the number of positions. They are infinite position control valves, and its graphical symbolic representation is as shown. The valves which allow any positions between fully open and fully closed positions of the valve to regulate either pressure or flow are called the infinite position valves. And these valves are also called as analog valves, and the simplest example is considered as a water tap. Now coming to the second type is called as finite position valves, and the graphical symbolic representation you can see here. The walls having definite positions between fully open and fully closed, that is either closed or open, there is no no partial opening, are called finite position walls. And these walls are also sometimes called as discrete position walls. Based on the other classifications of the wall, based on method employed for controlling the flow medium or the type of valving element used inside the wall body, we can call it as a spool wall, again subclassified as sliding as well as rotary spool wall. Then coming to another classification as seating wall, either it could be a ball, plate, or a cone, which is nothing but a puppet wall. And coming to the function and what hydraulic parameter of the fluid medium is going to be controlled, we can call it as a direction of flow, pressure of flow, and quantity of flow, that is the discharge or the flow rate, as well as to stop flow or to allow the flow in one direction only. And the control of pressure, flow rate, and the direction of flow medium are of prime importance in majority of the hydraulic system. And the name of the wall body depends on the primary hydraulic energy parameter, the flow parameter to be controlled. Based on this, we can call it as a direction control valves, pressure control valves, flow control valves, and the check valves. Now, out of which we will consider the first type is called as direction control valves. A direction control valves, as the name indicates, allow, stop, and control the direction of flow of fluid for reversing the direction of motion of the actuator. Although the direction control valves share the common function, but they vary considerably in their construction and operation. Upon classifications, a direction control valves are classified based on many factors. So out of which one is called as internal valving element. Either it could be a poppet or a spool valve. Again, spool valve will be further classified as sliding as well as rotary. And the second method of actuation, we can call it as manual, mechanical, electrical, hydraulic, or pneumatic actuation, or it could be a combination of the any of the method. Then coming to the third type, number of paths based on the flow, either it could be two-way, three-way, or four-way, etc. Then method of connection of the hydraulic circuit, it could be a pipe thread, straight thread, a flagged or manifold mounted, and the other parameter is called as the size. And the direction control valves can be of either finite position or infinite position valve, but majority of the direction control valves used of finite position type only. And these valves direct the fluid by opening or closing the flow paths in a definite valve position. As mentioned just now, each finite position is represented graphically by a square block and the arrow inside the square block showing the flow path. Now let us understand the terminologies which are associated with the valves. The first one terminology we call it as a port. The port indicates the openings on the valve body for interconnection between the pump, system and tank. One of the methods for designating a valve is by number of port. For example, M by N valve, where M always refers to the number of ports. Then coming to the position, position of a valve does not refer to the location or orientation in the hydraulic system, but to the position of the internal valving element that can occupy the valve when actuated. The resultant flow condition is determined by a perpendicular position of the valve. The possible number of positions in a valve is used to designate the number of positions of the valve. For example, in the previous term, the valve designated by M by N, M was the number of positions of the valve and was referring to the number of ports N of the number of positions. For instance, 4 by 2 valve refers to 4 ports and 2 positions. Normally, direction control valves have 2 or 3 positions, which you can see by this figure. The top positions we'll call it as single position, 2 position and 3 position. And coming to ports 2, 3, 4 and 5 ports, you can see in the figure. Each positions of valve is designated by a square block and number of adjoining square blocks indicates the possible number of positions of the valving element which you can observe. That is what we have discussed right now. In multi-position valve, the number of ports are shown only in a one square block which is you can observe in the figure. Now the 4 by 3 valve means 4 ports and 3 positions. 2 by 2 valve means you can see the figure, and 5 by 3 walls accordingly you can see the things. Then coming to the way, the term way refers to the flow path through indicating reverse flow. A direction of flow is denoted by a line with a shaded arrow you can observe in the figure over there. Then coming to the next terminology called as naming of ports. The ports on the walls are named using alphabets to give a specific meaning, like P, A, B, and T are the alphabets used to name the ports, where P refers to pump port, A refers to port to system, B refers to port to system, as well as T refers port to tank. And all these external connection, that is, the tank indicates the port is external connection to the tank. Similarly, others follow. Now you can see a 4 by 3 wall with the 4 ways and the center position off, and 3 by 2 walls with 2 way, which you can observe in the figure based on the naming of the ports. And you should make a note that a perpendicular line with a horizontal line at the port indicates the closing or opening of that port, which is represented over here. Then comes to normal and neutral positions. A normal or neutral position, also refers as a zero position of valve, is that the position when mounted on the hydraulic system. Generally, a majority of valves are normally closed valves, and the figure shows the normal position for different valves, which you can observe over here. Only the name of the ports for normal position is shown, and for other positions, the flow lines with an arrow are shown. And generally, the valves return to its normal position from the actuated position automatically, either by a spring or solenoid, and is called as the spring return or solenoid return valve respectively. Then coming to the types of DC walls and the graphic symbolic representations, you can observe it is a 2 by 2 wall and a symbolic representation you can see. And coming to the physical illustrations, it is 2 ports and 2 positions. Position 1 is nothing but P to A is going to be blocked, and position 2 is nothing but the flow is allowed to P to A. By this, you can see a various different positions and the type and the symbolic and the physical illustrations, which you can observe by seeing from this figure. Now, thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in the session. And don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Tawardhan.